Hey, this is Miss Callahan. We're going to go over volcanoes. Like I said, this is a quick overview, so you need to go and look into your notes for more. Volcanoes include activity of movement where magma, which is down below, comes out and surfaces into what we call lava. The major volcanic zones that we have happen at the mid-ocean ridge. And remember, we have a mid-Atlantic Ocean ridge, which is off the coast of us. And this is where plates are moving apart. And that's also known as divergent. Okay? Don't forget about your divergent plates. And here's a picture of that. So in a volcano, you're going to have a magma chamber, and the magma chamber is going to eventually have enough energy in here that it's going to erupt. Now remember that you have different types of volcanoes, and depending on the shape of the volcano and the lava is going to tell you what type of volcano that you actually have. These usually happen at subduction zones as well. In other words, you will have stuff, and I'm going to show you that real quick. So, like I said, volcanoes can happen at convergent and divergent plates. They do happen at your mid-Atlantic ridge, but they also happen when you have subducting plates. In other words, oceanic crust is going up under a continental crust. You also get this volcano that occurs as well. There are hot spots of volcanoes, which means that that's where you can find a lot of volcanoes all around our plate boundaries. Right here is showing us the Pacific Ocean, which is off of the coast of California, and you can see our different hot spots in the picture. So we have one here, 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 and so forth. Some factors that determine the violence of an eruption, like I said, are the composition of the magma, the viscosity, in other words, the temperature of the magma, and gases that are involved in the magma. So I've already went over what magma is. Remember, that is underground and lava is on the surface. Viscosity is just the measure of the resistance of the flow. So and this is all due to silica. If I've got high silica, I'm going to have high viscosity. If I got low silica, then I'm going to have lower viscosity. And due to that, you are going to get different types of lava flows and different types of volcanoes. We went over the different types of volcanoes, and we're going to go over that in just a minute. There's also a vent, or the opening in which the lava flows out. And our three different types of volcanoes are shield, cinder, and composite. And I'm going to show you those real quick. Shield volcano is really quiet lava flows. There's no major eruptions that happen. The lava is going to have a low viscosity, meaning that it's going to run very easily. So you're going to get this sloping or dome-shaped volcano. So I'm going to show you a picture of that real quick. Here's one, and then here's one as well. Mostly they are going to erupt constantly. You're going to have this nice, smooth, constant lava flow throughout. Now, you also have cinder cone volcanoes, which are more explosive. They have this very, what we call, well, I'm going to show you a picture. Okay, here you are. So, the cinder cone, you can actually see a cone around the top, and it's got much larger, steeper size than your shield volcano. So, here's a picture of one. And here's another picture, okay? Composite volcano, you're going to have explosive eruptions at first, and then quiet lava afterwards. And they look more like this. So they're very, very steep. They've got like this edge up at the top instead of the cone shape like you see in the cone. They're also known as stratovolcanoes, so don't forget that as well. Here's another picture of a composite volcano. Going into igneous rock, because igneous rock is pretty much lava and magma. Intrusive is going to be underground rocks that are formed from your magma, and extrusive is going to be above ground rock that is formed from your lava.